When we think about the role of a BI analyst, foundational skills like Excel, SQL, and BI tools are essential. They form the backbone of your ability to analyze data and build dashboards that monitor business performance. But if you want to stand out in a competitive field like business intelligence, it's always a good idea to explore techniques that go beyond dashboards. In this video, I'm going to talk about 5 advanced analytics techniques that can help you become a more valuable resource to any employer. They're techniques that are more in the domain of data science than business intelligence, but are definitely worth looking into if you are or are considering becoming a BI analyst. This video isn't designed to be a tutorial for these different techniques, more of an introduction to the tools and methods used to carry out the analysis. From understanding customer behavior to predicting future trends, these techniques are powerful, actionable, and highly relevant to the business world. Let's start with RFM analysis. And I've actually already done a tutorial video on this using Excel you can check out. I'll leave a link in the description. RFM, or Recency, Frequency, and Monetary Analysis, is a cornerstone of customer segmentation. It helps businesses identify who their best customers are, who's at risk of leaving, and who might need a nudge to re-engage. By breaking down customer behavior into these 3 factors, you can offer insights that guide things like targeted marketing strategies, loyalty programs, and resource allocation. It's a fairly straightforward but incredibly impactful technique. The way it works is this. You need purchase data containing a purchase date, purchase amount, then both order and customer identifiers. You then score each customer based on how recently they purchased, the frequency of orders they've made, and the purchase amount of those orders. You can then segment customers based on their score and give those segments names like champions, loyalists, or at risk. RFM segmentation is something that can be done either using Excel, see my tutorial, or dedicated tools, and I'll leave a link to this one in the description. Next up, market basket analysis. Have you ever noticed how e-commerce sites recommend products based on what other customers have purchased? That's market basket analysis at work. What it does is identify patterns and associations between products to uncover opportunities for cross-selling and upselling. The core idea of market basket analysis is to find relationships between items purchased together. This is often done using metrics like support, confidence, and lift. Support measures how often a product or combination of products appears in the dataset. For example, if there are 1,000 transactions in total and 100 of them include both bread and butter, the support for this pair is 100 divided by 1,000, or 0.1, 10%. Confidence evaluates how often a specific item is purchased given that another item has already been bought. For instance, if 100 transactions include both bread and butter and 200 transactions include bread, the confidence for bread leading to butter is 100 divided by 200, or 0.5, 50%. Finally, lift compares the likelihood of buying 2 items together versus buying them independently. So you calculate the support for each item individually, then calculate lift using the formula confidence divided by support of the second item. A lift greater than 1 indicates that the items are more likely to be purchased together than separately, thus highlighting a strong positive association. Anyway, like I said, this isn't designed to be a tutorial, so please do your own research if you want to learn more. So by analysing these kinds of metrics, you can uncover which products are frequently bought together or which items could be promoted as bundles. It can also be useful for optimising product placement in stores, refining promotional strategies, and enhancing customer recommendations on websites. If you want to check out an easy-to-use market basket tool, I'll leave a link to one in the description. Churn describes customers who stop doing business with the company. So churn analysis is a method used to understand why this happens and to predict which customers are at risk of leaving, which allows businesses to address customer concerns before it's too late, thus increasing retention and maximizing lifetime value. Churn can be defined differently according to a company's business model. For example, in a subscription-based business, churn might mean a customer cancels their subscription. For retail, it could be a certain period of inactivity. Churn analysis is carried out by analysing historical data to find patterns among churned customers. Factors like purchase frequency, time since last purchase, or customer support interactions. But literally any dimensions, including demographic data, can potentially influence why a customer churns. These patterns are then used to build a model that predicts churn. Common techniques include logistic regression, decision trees, or machine learning algorithms. Speaking of which, why not check out this video on my channel where I show you how I build predictive models using ML. So based on the insights, businesses can create retention strategies like personalized offers, loyalty programs, or improved customer service and onboarding. For example, if your analysis shows that customers are likely to churn after 3 months of inactivity, you could send a personalized email with a special offer to re-engage them before they leave permanently. Sentiment analysis helps businesses understand how customers feel about their products, services, or brand by analysing text data like reviews, social media posts, and survey responses. First, this text data is prepared by removing things like stop words, punctuation, and irrelevant information. Then this data is run through natural language processing tools that classify the sentiment of the feedback as positive, negative, or neutral. Sentiment scores can also be applied that quantify the strength of emotions. The principal goal of this analysis is to identify trends in customer sentiment over time, pinpoint recurring issues, or highlight what customers love most about your offerings, so that businesses can do more of the same. For example, if a surge of negative reviews mentions delayed shipping, you can investigate your supply chain and delivery workflows to identify and address the root causes, ultimately improving customer satisfaction and experience. Tools for implementing sentiment analysis range from open source options like NLTK, TextBlob, and Vader, to more advanced solutions like Google Cloud Natural Language API, IBM Watson Natural Language Understanding, and Microsoft Azure Text Analytics. The last of the 5 techniques we're going to focus on is regression analysis, which is an oldie but a goldie. In fact, it goes back as far as the late 1800s. Essentially, regression analysis is a statistical technique that's used to examine the relationship between variables. It helps businesses understand which factors, such as pricing, customer demographics, marketing spend, or operational metrics, have the most significant impact on their outcomes, such as revenue growth, customer retention rates, or operational efficiency. I did a video demonstrating simple linear regression a while back that I'll put a link to in the description. Here's how regression works. You first need to identify what's called the dependent variable, which is the outcome you're trying to explain, and the independent variables, the factors that might influence it. For example, sales could be your dependent variable, and price, advertising spend, and customer behavior patterns could be your independent variables. You start by using tools like Excel or statistical software to create a model that explains the relationship between your variables. Linear regression is the most common type and assumes a straight line relationship between the independent and dependent variables. Once the model is fitted, you then examine the coefficients it produces. Each coefficient represents the strength and direction of the relationship between an independent variable and the dependent variable. A positive coefficient indicates a direct relationship, for example, higher advertising spend leads to increased sales, while a negative coefficient suggests an inverse relationship. You can then use your regression model to simulate outcomes under different scenarios. For instance, if the coefficient for advertising spend is 2.5, you can estimate that every additional $1,000 spent on advertising will result in a $2,500 increase in sales, all things being equal. Regression analysis is great for uncovering actionable insights, such as identifying the key drivers of revenue or understanding how changes in strategy might impact performance. So why should a BI analyst care about these techniques when they're more the job of a data scientist? The answer is simple. Businesses are always looking for actionable insights that go beyond what dashboards can show. By developing an understanding, or better yet, technical expertise in these methods, you can position yourself as more than just a dashboard creator. You become a strategist who can identify problems, uncover opportunities, and deliver measurable value for any business. If you're an independent BI consultant, these advanced techniques can serve as powerful tools to showcase your experience, attract new clients, and provide additional value to existing ones by offering enhanced, data-driven solutions tailored to their needs. And the best part? These techniques are within reach. Whether you're working with off-the-shelf tools or building your own workflows, you can start exploring these methods today. Don't forget to check out the video description for links to everything I've talked about in this video, and here's the video I mentioned earlier where I go into more detail on RFM analysis. If you found this video insightful, be sure to like, comment and subscribe, and let me know in the comments which of these techniques you'd like to see covered in a more detailed video in the future. Until the next time, bye!